Okay, so let's get started, please. If you're following along in the lecture notes, we're on creating, moving, removing, and copying files. If we go really quick, we'll be able to get through the permissions notebook as well, but I don't think we're going to get there. All right, so creating, moving, removing, and copying files. So at the top of this notebook, there's a quote from one of the original developers of the Unix file system. So it's by a guy named Eric Raymond. He also wrote this book called The Art of Unix Programming, which there are free versions of this book online. Actually, that's his link right there to the book. It's an interesting read, although I'm not sure you're quite ready for it yet. If you're interested in like software and the history of software and things like that, it is a good read. It's not very technical, this book. It's very long, but it's not very technical. Okay, so the important part in this quote, though, is that this thing right here. Right? When Unix was first developed, there were a bunch of ideas that they had, and they put into and they implemented. Part of the amazing part about Unix is that it's still around today, 50 years after it was created. And you have to remember, like, the computers of 1970 are very different than the computers of today. And the fact that this operating system is still around and forms the foundation of operating systems like Mac OS is pretty amazing when you think about it, especially given that software is often written to be thrown away now. But in Unix, there is this idea that everything is a file, which is strange when you think about it, but that's the way it works in Unix. And so whenever you do input or output, so whenever you read something or write something, so read from a device or write to a device, the metaphor that's used in Unix is that all of those reads and writes go through some kind of file. Right? So that means you can access a regular file or a directory or a storage device. Things like your keyboard, right? They're all accessed using the same idea. Right? And so basically what happens is the access to these devices, they go through files. Right? So when I want to read something from a terminal, you can think of it as actually reading a file that's connected to the terminal. When I want to write something to a terminal, I just write something to a file, and that file is also connected to the terminal. Right? If I want to read something from a hard drive, there's actually a file on your Unix or Linux file system that corresponds to your hard drive. So when you write to it, you're just writing to the file, or that's what it looks like to the user. Right? You write to this file, and that file ends up writing to your hard drive. Right? So underneath the hood, the operating system takes care of dealing with all of the nitty-gritties of trying to write to a physical device. Right? But to the user, you're just writing to a file, and that makes life really easy. Right? Okay, so what most people think of as a computer file is just a bunch of bytes, right? So it's just a bunch of ones and zeros, right? So reading the contents of a file, you're just reading a stream of ones and zeros, right? Writing something to a file, you're just writing a stream of ones and zeros. Right? And that's how everything works in Unix, right? So that's the underlying metaphor that's used in Unix. And it's one of the APIs that you can use, so that we can actually use in this course, to write write and read information to and from devices. Okay, so if you're running this notebook, you need to run this cell once, and then everything will be in the right directory. All right, file names. So if everything's a file, then you need to know how to access a file, right? Which means you need to know how to use file names. So we went over this yesterday. Yeah, it was yesterday, right? So in Unix, there are no illegal characters in a file name except that, right? So you cannot use the / in a file name, and you cannot use \0 in a file name, right? You can't use the / because that's the directory separator in Unix. You can't use \0 because that is what terminates a string in C, and your operating system is written and Unix is written in C. So no \0 in a file name either. Right? File names are case sensitive, so little abc is different than big abc. Right? Anything file name that starts with a period is a hidden file. Right? From yesterday's lecture, you know that you should avoid characters like that in a file name. right? Because you have to, if you have those in a file name, you have to deal with them specially. White space is, also falls into the same category. You have to avoid, or you have to suppress, you have to suppress white space expansion or word splitting if you use spaces in a file name, right? If you want to separate words in a file, it's easier if you use the underscore. And you should avoid the hyphen as the first character of a file name, right? Because remember, most commands, if they take in an option, it's hyphen something. So if you have a file name that starts with a hyphen, that looks like an option to most commands. And now you have another problem. All right, so this is important here. If you actually start to Google for stuff, and you will start to Google for stuff when you start to search for questions relating to the assignment problems, right? You're going to run into a lot of advice saying you shouldn't do this, you shouldn't do that, you have to do this, you have to do that, right? Most of that advice is devoted to explaining why certain constructs are needed because of the existence of unusual file names, right? So keep that in mind when you're reading anything on like Stack Overflow or something like that. All right, so we don't know how to create a file yet. So the obvious way to create a file is you open up some application, right? So you use Visual Studio Code, or you save a file from your web browser or something like that, right? And that'll create files for you. You can actually create files from the command line as well, right? So there's a command called touch, right? So the touch command will create one or more named files if they don't already exist. So it makes you an empty file, right? All right, so I'm going to run this code cell right here. So we're in this directory. Where are we here? So we're in the scripts/files directory. If you have run the notebook already, then you're going to get different results because this notebook creates files for you. So I don't think I've run this yet in this particular directory, right? So when I list the contents of this directory, hopefully this works. Okay, so this, oh, sorry. I have to make it a little smaller so you can actually read everything. Okay, so when I list the contents of that directory, right, I get a.text, dir1, file1, word starting with a, right, which is not supposed to be there, but it's there, never mind. Right? Okay, I then use the touch command to create these two files, right? So if I now insert another cell, insert another cell below that, and enter the ls command and run that, right? You're now going to see that there's files called file2 and file3, right? So the touch command creates new files if they don't exist, right? And then they're empty files. Okay, so if a file already exists, then touch updates the access and modification time of the file to the current time. Right? Okay, so I'm going to run this cell here. So file1 already exists on this computer, right? So I'm going to run the ls command, look at the modification time. Then I'm going to touch the file, and then we're going to look at the modification time again. Okay, so run that. So that's the modification time of file1 before I touched it, right? After running the touch command, right, that's now the modification time of file1, right? So touch, if a file already exists, then touching the file updates its modification time. Right, so that's one way to create an empty file from the command line. All right, now what about directories? So can you also make a directory or an empty directory? And the answer is yes, right? So the command to make a directory is called mkdir, so make dir. Right? The make dir command creates one or more named directories. Okay, so I'm going to print out a little message here, right? So I'm going to list the contents of the directory before running makedir. Then I'm going to run makedir, right? I'm going to make two directories, dir2 and dir3, and then I'm going to print another message and then list the contents of the directory a second time. Right? So if we run that, so before makedir, we've got these files in directories, right? After makedir, I've now got two new directories right here. Right? And notice that they're color-coded, so Jupyter is set up to color-code the cells. Your bash shell is probably set up to color-code the names as well. Right? If you're using the virtual machine, I guess, oh, there we go. So this is in bash scripts and then files. So in bash, it looks like it's the same color coding. Right? So anything shown in blue is probably a directory. Anything shown in gray is just a regular file. Okay, now what if you want to make a hierarchy of directories? So I want to make, in this case, I want to make a directory xx, x, and then in that directory, I want to make a directory YYY, and then inside that directory, I want to make a directory ZZZ. Right? This turns out to be pretty common when you're organizing stuff on your, when you're organizing information for some reason. You end up with many directories. Right? In Java, this happens all the time because you have to create the package structure corresponding to your classes. Right? And the package structure in Java is just a nested directory structure. So if you do this, that fails. Right? So it complains, I can't make XXYYZZ, no such file or directory. Right? Now, it doesn't tell you what the missing file or directory is, but it turns out in this case, when you write this, right, it tries to create the directory ZZZ in the directory XXXYY. Right? So it's the directory XXXYY that's missing. Right? Okay, now, you can fix this. Right? You can do this manually by making the directories one at a time. Right? So I make directory XXX. Right? When that's done, I make directory YYY inside of XXX. Right? And then you can do ZZZ inside YYY. Right? But makedir, whoever wrote makedir is not an idiot. They gave you an option to create all of the parent directories that are missing. Right? So makedir minus P, XXXYYYZZZ, will create XXX and YYY if they don't exist. Right? So if you run that, you can now see that I have a directory XXX. Inside that, there's YYY, and inside that, that's ZZZ. Right? To get that output, that's the tree command. So that I use the tree command to generate the figure that's in your assignment. Right? That shows you the directory structure of your assignment. Right? The dot, of course, is the current directory. Right? So you can see that in the current directory, there's a file called a.txt. Right? There's a directory dir1, dir2, dir3, and so on and so on and so forth. Okay, so that's makedir. So now we know how to make an empty file, and we know how to make an empty directory. Right? So what if I want to put something into that file? Right? Again, so you just open up a text editor or some other editor and edit the file that way. Right? If you want to run a command, though, and you want to save the output of that command to a file, then the shell gives you an easy way to do that. Right? So the way to do that is with what's called a redirection. Right? So redirecting command output. So most of the Unix commands, a lot of Unix commands anyway, they generate text as their output. Right? So that's another one of the underlying metaphors in the Unix file system. Right? Everything's just a stream of text. Right? So commands generate text as output, they accept text as input. It's possible to send the output of a command to a file. And the way you do that is you use this greater than operator. Right? So that's called the redirection operator. So that redirects any of the non-error output of a command. So if there's no error, if the command does not encounter an error and it generates some text, then it redirects that text to a file. Right? And it'll overwrite the file if it already exists. Right? So that command right there, right, runs the cowsay command. Right? Remember, cowsay prints a cow that's saying moo. Right? And then instead of printing that to the terminal, it redirects it to the file called moo.txt. Right? So if I run this command, you'll get no output because the output that would normally go to the terminal is now redirected to the file. Right? If you now look inside the file moo.txt, right, you see the cow, you see the output of the cowsay command. Right? So redirection with a single, I guess greater than sign, right, always overwrites the destination file. Right? Unless you've got your shell configured not to do it. So there's a way to configure your shell so that it does not overwrite the file. but most default installations of bash will always overwrite. Okay, now what happens if you don't want to overwrite, but instead you want to add to the end of it? Right? So this is another common operation. So you might be keeping a log file, for example, of the output of your program. So your program runs a long time. Right? Every once in a while, something happens, you want to output it to a file, and you want to keep track of all of this output. Right? So that's where you want to append to the end of the file instead of overwriting the file. Right? So greater than appends to the end of a file. If the file doesn't exist, it makes the file and then writes to it. Right? So if I run CISC again, and this time append to an existing file, right? Again, no output, because all of the output gets redirected to the file. Right? So now what's inside this file? Well, there's the original output from the output from the original CISC, and now there's the output to the second CISC. Right? So now you've got two cows in your file. Right? So double greater than, that's redirect and append to a file. Right? Single greater than is just redirect and overwrite. All right, so there's a simple way of saving the output of a command to a file. All right, so now that we've got some files and they're not necessarily empty, what about moving them around? So what happens if I want to rename a file, or if I want to take a file, move it to some other directory? So that's what the command mv is for, right? mv is short for move. Right? Notice the creators of these commands are very lazy, and they don't spell out the command names in full. Right? It's because you have to type these all in, and it takes a long time to type. Right? So a lot of the command names are abbreviated. Right? mv moves or renames a file. Right? So to rename a file, it's mv. Right? Then it's the file name of the file that you want to change, or rename, sorry. Oh, sorry, hang on. I'm editing the cell now. Okay. Right? And then space, and then the new name of the file. Right? So that'll be the renamed name of the file. Okay, so for example, I'm going to make a file called a file. Right? Then I'm going to rename a file to b file. Right? So we run that, you have a file called b file here. Right? So the command to rename is not called rename, unfortunately. It's mv. Right? Okay. Now, you can rename a file and move it to another directory at the same time. Right? So the destination for the file, right, the renamed name, does not have to be in the same directory. Right? So I can now take our file called b file, and I can rename it to c file, right? But c file is now in the directory dir1. Right? So this effectively moves and renames the file to a new location. Right? So if I run this cell, right? So I move it to dir1, right? And then I do ls. Notice that sorry, this is a, okay, so that's the output from the first ls, right? So notice that b file is gone, right? Now when I list the contents of dir1, that's where c file appears, right? So we've moved that file, oops, sorry, we've moved that file to another directory and renamed it at the same time. If you just want to move a file and not rename it, so I want to move it to another directory, then you leave off the file name. Right? So I'm going to make a file called z-file, and then I'm going to move z-file to the directory dir1. Right? So notice there's no file name after dir1 here, because I don't want to change its file name. I just want to move it to a different directory. Right? So if I run that, so there's the output from the first ls. Right? Notice that z-file is gone. Right? But when I look inside dir1, there's my file, there's the file z-file and the file c-file, right? And a.txt and a.words.txt apparently. Okay, so if you rename or move a file, and the new name of the file, there's a file that already exists having the same name as the new name, then move automatically overwrites the file. Right? Okay, so what do we have in here? Okay, so we've got file 1, file 2, file 3, right? So hang on, let me put something into file 1, file 2, and file 3. So I'm just going to do CISC again. CISC hello. Oh, I know. I'll do file 1, and I'll redirect that to file 1. And then I'm going to do the same thing for file 2. Right? So if I look in file 1, it's going to be the cow saying file 1, and if I look at file 2, it's going to be the cow saying file 2. Right? Now, suppose I accidentally or on purpose, right, move file 1 onto top, so rename file 1 so that its name is now file 2. Right? That overwrites file 2, and it does it silently. Right? So the bash doesn't warn you at all. Right? It just overwrites it. So if I look at what's inside file 2, right, it's now the cow saying file 1. Right? So it's overwritten the file 2. Right? And of course, file 1 is no longer there because I moved or renamed file 1 to file 2. Right? So people who are used to, people who are used to working in bash expect this to happen. Right? So they know that overwriting is the default behavior. If you want to avoid overwriting, or if you want a prompt that asks you, do you really want me to overwrite this file? Right? So for example, suppose I try to move file 2 onto file 3, but this time I give it the option -i. Okay? So -i is interactive mode. Right? It now asks you, do you want to overwrite file 3? Right? If you say no, N for no, it will not. If you say yes, it will. Right? So if I say yes, file 3, right? So notice there's no file 2 anymore either. And if I look inside file 3, right, it's again our cow saying file 1. Right? So the -i option puts the command into interactive mode. It will always ask you if overwriting is about to happen. Right? So mv -i -i file 3. So if I try to rename it to file 4, it'll just do it because there is no file 4. Right? So it just moves it. Right? So -i warns you it's about to overwrite. Okay, unfortunately, these interactive prompts, they don't work inside of Jupyter Notebook, right? So the Jupyter Notebooks can't, they're not set up to, well, it won't accept interactive input, unfortunately. So if anything, if there's ever an example that involves you typing something into, typing in information, it has to be run from a real terminal. It can't be run from a Jupyter terminal. All right, so that's moving or renaming files. Now, how about removing files? Right? Now, there's another warning from Eric Raymond here. Right? So in Unix, file deletion is permanent. Right? So that's the way the file system was designed. Right? There's no reliable way to recover a file if you delete it or overwrite it. Right? People will try to sell you ways to do this. They don't always work. Right? And it certainly won't work if you overwrote something a long time ago and then several weeks later decide that you want it back. Right? There's no way to get it back. So before you start removing stuff on your file system using the remove command, or before you start overwriting files on your file system using mv, right? Remember that anything you do is permanent, right? If you delete something, it's gone forever, right? So you've been warned, right? Okay. This is actually, the fact that Unix deletion of a file is permanent is actually considered one of the design flaws of the Unix file system. But it's been around so long that everybody just expects it now. Okay, so I'm going to create some empty files, a.txt, b.txt, c.txt, d.txt, and e.txt. Right? So let's do that. So there they are, right? A, B, C, D, E. Right? The rm command removes a file, right? So if I write rm a.txt, b.txt, it's going to remove a.txt and b.txt. Right? So notice A and B are gone, right? And the first file is c.txt. Right? You can use a wildcard expansion here, or a file name expansion to remove everything called .txt, or everything that ends with txt. Right? So if I run rm star txt, that deletes everything starting with txt. Right? Notice this thing here now appears funny, so I'll explain what. Hopefully, I'll get to the end of this notebook and I'll be able to explain what's going on there. Right? But all of our all of our files that end in txt, they're now gone. Right? Now, if you want to avoid this from happening, right? So if you want to avoid, or if you want to individually pick which files get deleted, you can run RM in interactive mode as well. Right. So let me make some more files. Oh, it doesn't matter. All right. So just like MV, there's a -I option for RM. Right. So I guess star dot t star. So I'm going to try to remove those files that I just created. Right. Now it's going to ask me for each one, do you want to remove it? Right. So I'm going to say yes, and then no. Right. And you can see that it's removed a.text, b.text, but left c.tt alone. Right. So if you want to, you can run RM in interactive mode again. Again, for most bash installations, the default behavior is not to run in interactive mode. It used to be the case where you would come into university, and the first thing that would happen to you is that you would walk into this room with a bunch of computers, and they'd all be running Unix or Linux. So that's what happened when I started computer science at Queen's. Right? So all of our workstations were some sort of Unix workstation. And there, the systems would be set up intentionally so that RM always was alias to RM-I. Right? So it would always ask the user, do you want to remove stuff? Right? So in teaching environments, it's common to see RM and MV aliased to RM-I and MV-I, so that it always prompts the user if overwriting is about to happen, right? Or if deletion is about to happen. But it's uncommon everywhere else. Okay. Where's our? Okay, so RM on its own will not remove a directory. Okay, so if you want to remove a directory, is that the best way to put it? No. If you want to remove an empty directory, then the way to do it is with the command rmdir. Right, so I'm going to make an empty directory here called sumdir. Right, so there's my directory sumdir. It's got nothing in it. Right, so it's an empty directory. I can remove the directory using rmdir sumdir. Now, if I just try to use RM, right, because I just told you RM removes files, right, RM will complain, right? It says I can't remove sumdir because sumdir is a directory, right? Now, if you type in rmdir sumdir, then it's perfectly happy removing the directory, as long as the directory is empty, right? If there's something in the directory, right, so I'm going to make a directory called sumdir again. I'm going to create a file inside that directory, and then I'm going to try to remove it. Right? rmdir fails again. Right? So rmdir will not remove a directory if it's not empty. Right? Now, so that begs the question, how do you remove a directory if there's stuff in it and you really want to delete the directory and everything that's in it? Right? Well, the answer is you use rm, but this time you pass it the option -r. Right? So -r means recursively remove everything that's in that directory, right? So RM-R really will kill everything that's there, right? And it won't complain about it, so it's gone, right? If I do, right? So if you do ls in that directory, there is no directory called sumdir, right? So make dir sumdir, right? Touch some file, right? And then RM-R sumdir. Right, sumdir really is gone now. Right. Okay, now be very careful with -r. Right. So in particular, especially if you're running your Linux, your Ubuntu, your Linux installation as root, and I know at least one person that's happened to because I accidentally told them to do it that way. If you're root, so if you're not a regular user, and you do RM-R in your root directory, you will delete your entire operating system, right? And you laugh, but if you Google for it, right? If you Google RM star in root directory, right? The first thing you get is a stack, I guess this is a Stack Exchange, same as Stack Overflow, right? What would happen if I did RM-RF star in the root directory, right? Well, it tells you you're going to delete your operating system. Right? And then here, the second one is I accidentally typed in RM-RF in the root directory, right? And that nukes your directory. So it has happened. There are system administrators who are still employed that have accidentally deleted a working operating system. So don't do that. Right? So be very careful when you're removing files off of your operating system. Right? Whatever you do, be extremely careful if you're root, if you're logged in as root. Or if you've been looking online and you see this command called sudo, be very careful if you're using sudo or superuserdo with RM. Yes? Hi?
Oh, if you add a -I, would it warn you? Or is it
Yeah, it will warn you. So F means force. So -RF means recursively remove and don't ask. If you do -RI, it will ask you every time. If you're removing a lot of files, though, the -I is really annoying because you have to hit Y or N for every file. Yeah?
So you can do stuff like -RI as opposed to -R and -I.
Sorry, what's that part? One more time?
Can you put two, let's say, options together?
Yeah.
Hit them like -R and -I, or can you do -R?
You can do both. Most of the time, you can do both.
Okay.
Yeah. Yeah.
I was like kind of gonna ask the same question. Like I noticed when I was looking at the assignment,
Yeah.
you do like ls-al
Yeah.
and ls-la.
Yeah.
Sometimes it won't have the same output. Like what is the?
As long as the two letters are the same, exactly the same, the output should be the same, regardless of the order. Yeah. The error there might have been a capital A and a lowercase a. That'll give you different output. Yeah. All right. Copying files. Okay, so what about if you want to copy files? So I want to make a copy of a file. Again, this is a very common operation, right? You might want to make a backup of a file before you edit it in case your edits turn out to be incorrect. Right? This is especially true if you're doing programming, for example, right? So when you start writing, when you start to write some C programs or when you start to write some shell scripts, if you have something that's already working, right, you might want to make a backup of that file before you edit it again and make some permanent changes to it, right? I mean, ideally you would be using some sort of version control like Git, but if you're not, you can always make a backup of your file yourself, right? And so that's what copying file, that's one example of a use of for copying files. Right, so to copy a file, it's just CP, right? The file that you want to copy, and the file of the and the name of the copied. Sorry, fname is the name of the file you want to copy. New name is going to be the name of the copy, right? So it will create a copy of fname and save it as new name, right? So I'm going to make a copy of a.text. Oh, I deleted it, didn't I? Yeah, I deleted that. Hang on. Okay, but I think I have a backup of it in dir1. I do. So I'm going to move. Yeah, I'll just move dir1. A.text to here. Okay, so now I have a.text. So I'm going to copy a.text to, I think it's a, what do I call it? A words.txt. Right, and now you have two files, a.text and a words.txt. Right? If I look at their, well, let's look at the contents. So there's a.text. Right? It's just a bunch of words that start with a capital A. Right? Starts at the single A, goes to AFAIK. And if I look at a words.txt, it's the exact same thing. Right, so it makes a byte for byte copy of the file, saves it as a new file name. You can copy multiple files at once as long as you put them into another directory. Right, so unfortunately what you cannot do is you cannot copy multiple file names at once and then specify some sort of pattern to rename them to, right, which is often very handy, but you can't do it, not with CP anyway. So with CP, you can copy a whack of files, put them somewhere else, right? So for example, I can copy all of my files that start with the letter A and end in txt, and I can put them into dir1, right? Let's run it from here. Sorry. Control. There we go, right? So I've copied a.text and a words.txt into the directory dir1. And if you want to copy a directory, it's the same command, except you use the option -r. So again, recursively copy the directory and all of its files. So cp -r dir1 to words will copy the directory dir1 and all of its contents into a new directory called words. Right? So if I run that command there, and then look at what's here, right? So there's now a directory called words, right? If I look in what's inside words, I've got those files there. And if I look at what was in the original directory, I've got the same files there, right? And they're independent copies here, right? So those are independent files. Those files are independent from these files here, right? So there's no aliasing or referencing going on here. All right. So what do we know how to do now? We know how to create some files. We know how to move them around, rename them, delete them if we wanted to, right? Copy them. And so now we get to this topic called linking. All right, so I guess a few days ago now, I told you what a hard link was. Right? So just to remind you what a hard link is. Right? So a hard link is a directory entry that maps a file name to an inode. Right? So remember, in Unix, the file name doesn't actually, where your data is stored is different from the file name. Right? The file name is stored in a directory. Right? Associated with every file name, there's some number called an inode. Right? So here the file a.text has this inode 65532. Right? So that inode you can think of as just being a reference or an array index or something like that, however you want to think about it, right, to where this thing is stored on the disk. Right? dir1 that's a directory, but it's also a file, so it also has an inode. Right? File1, just a regular file, so it has an inode as well. Right? If you want to look at the inode numbers, one way to do it is to use -i, lowercase I. Right? And that will list the files and their inode numbers. I'll make it a little easier to read like that. Right? So if you ever want the inode, most of the time you don't care about the inode numbers. Right? Like almost all the time you don't care about them. Right? But if you want to look at them, you can look at them. I think here they're all, are they all unique? What's this one? Yes, they're all unique here. Right? So all of these inode numbers are unique. Long listing. Okay, so why do I care about the, oh yeah, long listing. Okay, so let's look at the long listing. Okay, so same example. This time I'm going to use L. Right? So this will give you more information about your files. Right? Again, the inodes are here on the left-hand column. Right? But now you've got these numbers 1112 to 1213. Right? So that column there, that's the number of hard links associated with the file. Right? So a.text, there's one hard link. Right? A words.txt, there's one hard link. For directories, it's the number of hard links inside the directory. Right? So if you look inside dir1, you'll see that there's 4 files. Four files. Now I'm 100% sure what I just told you was right. Number of hard links to each inode or the number of hard links in a directory. It's correct. So why am I getting 2? That's a mystery. No, hang on. That's supposed to be the number of hard links in a directory. All right, hang on, I gotta make a note of this because I have to find out what's going on so that I can explain it to you properly next time. Sorry, give me a second here. Why is the number of hard links? Okay, so we'll figure that out next class. Okay, so yeah?
Do directories have hard links too?
Yeah, directory is just a file, so it also has a hard link. Yeah. Okay, so hard link. So name, right, mapped to a number. Now the question is can I have 2 different names mapped to the same number? And the answer is yes. Right? So I can have two different file names associated with the same inode. Right? And so what that means is you've got two names that both point to the same file, right? That both refer to the same file. And the way, if you want to create that, you can do so using this command called ln. Right? So I can link, or I can create these hard links using the ln command. Right? So if I write ln a.text, so that's your, that's your target, right? So that's the existing file that I want to make a hard link to, right? I can create a new file that links to the exact same, that has the same inode number, right? So links to the same location. Right? So if I do that, and now do this, oops, sorry. Okay. There we go. Right. So now I've got A, that's my new hard link, right? And I've got a.text, that was the original link, right? So a.text maps onto that inode. A now maps to this inode here, right? So they map to the same inode. And what that means is they're both effectively the same file. So they're pointing to the same data on your disk, right? So if I output A, the contents of A, right, it's that file there. If I output the contents of a.text, it's the exact same. Now, if I use A to edit the file, so I'm going to delete the first line and then save it out, right? So there's A, right? So notice that the first A is gone. And if I look at a.text, the first A is also gone, right? So why does that happen? It's because both file names are pointing to the same file. So if I edit either, if I use either file name to edit the file, both files, well, sorry, you'll see the change regardless of which file name you use. Right? So you've got two names pointing to the same file. Oops, sorry. Right? So that's what a hard link is. Right? Okay, now what happens if I remove one of these files where the hard link, where the inode, where they have the same inode, right? Okay, so one more time. Right, so a.text and A, right, they both point to the same inode, right? So they both map to the same file node. So if I remove A, does that also remove a.text? Right? And the answer is it does not. Right? It does not. Right? And if you think about this for a few minutes, right, or maybe not a few minutes, so if you think about this, you'll quickly realize why this didn't happen, right? Why it didn't remove a.text as well, right? So in other words, the contents of the file are still there, right? So the inode still exists, right? Whatever data, whatever information that inode is in that inode, it's still there, right? Okay, so the reason removing the file doesn't actually change, doesn't actually delete the contents on the disk is because you haven't actually removed the file. What you've done is you removed the file name. Right? So you've gone into the directory and removed the file name that's in the directory. Right? So I've removed the file name A that's in the directory files. You haven't actually deleted the data that's associated with the file. Right? Because there's another file that points to the same inode, right? The actual contents of the file are not deleted. Right? So the inode's not deleted. Right? The file name's gone, but the inode itself is not gone. Right? There's still another hard link to that inode, so the data that's there is not removed. Right? Oh, if we do ls minus L again, that number there. So that was 2. ln a.text, oh, wait, I think I just screwed, no, that's right. Right? So notice that A and a.text, right, their hard link count is 2. Right? So it's indicating that there's 2 things pointing to the inode. Right? If I remove either A or a.text and do the same thing again, right, the hard link count goes down to 1. Because I just removed one of the hard links to that inode. Okay, now if there's a hard link, is there a soft link? And the answer is yes, right? So there's something called a symbolic or soft link. Okay, so remember, a hard link maps a file name to an inode. A soft link links a file name to another file name. Right? So if you want to think of these as references, then a file name is just a reference to an inode. A soft link is a file name that's a reference to another file name. Right? So you use the same command and use it in the same way to create what's called a soft link. Right? So here I'm going to create a soft link called that points to the file name a.text. Right, so I'm going to run that. Oh, it already exists. Okay, so that's good. So it's already there. So let's go look at it. Oops, sorry. So when I type in ls, if you see something in this color that's not a directory color or a file name color, it's probably a soft link. Right, so this greenish teal color here, that's a soft link. If you do ls minus l, you'll see that there's an L in the first column, indicating that that's a soft link. When you look at the output, right, you'll see that word starting with A, you'll get this little arrow and says a.text, right? So what it's trying to tell you is that word starting with A, it's a file name, but this file name is actually pointing to the file name a.text. Right? So in other words, word starting with A is just another name for a.text. Right? If I use word starting with A to look at the contents of the file, it prints out the contents of the file. What does it really do? It prints out the contents of the file a.text. Right? So that prints out the contents of the file a.text. Right? Oh, sorry, I'm trying to scroll and it's not working. There we go. Right? So what happens if I edit the file using words.txt? Right? So let me delete the first line again. Well, let me delete a bunch of lines. Okay, so there we go. Right? And if I output a.text again, yeah, the file's changed. Right? So you can edit the file using either file name. When you open it up again, the file contents will have changed with either file name. Right? Now what happens if I remove the file a.text? Right? So if I remove the file a.text, right? So a.text is gone. Notice that this right here, right, is now in red, right? And it's trying to indicate to you you've got a link that doesn't point to anything, right? So that link, that soft link, word starting with A, used to be a reference to this file called a.text. But there is no file called a.text here. So that link is now what's called a dead link or a dangling link. If you try to use it for anything, right, you'll get an error. Right? There is no such file or directory. Right? Because there isn't. Right? There is no file called a.text. Right? Okay, so that's the difference between a soft link and a hard link. Now you might wonder why you'd use these on your why you'd ever use these. Hard links are a little uncommon. Soft links, however, are not. Okay? So soft links, if you go and point, hopefully I get root bin. So if you're on a Linux system, if you go into bin and type ls, first of all, you'll see there's a bazillion files. But what you'll also notice is that a lot of the commands are actually links. They're just soft links to other commands. Right? So xzcat is just a soft link to the command xz. Right? And so on and so on and so forth. Oh, this one's it. Here we go. That's a link to some file in some other directory. Right? And so this turns out to be extremely common on a Unix or a Linux file system. Right? A lot of your files, a lot of your operating system files are actually soft links to other files somewhere else. Yes?
What's the difference between a soft link and an alias?
So an alias is not a file. So that's number one. An alias is just a name for is just a different name for another command. All right. Any other questions? All right, everybody. I'll see you next week. Everybody have a good weekend.